Okay, so this is the explanation part of section 3.1. We had the formula that said if we had f of x is equal to a times x minus h squared plus k, our vertex was hk. And then when we have f of x equal to ax squared plus bx plus c, we were given our vertex as negative b over 2a and then f of negative b over 2a. I'm going to show you why this ends up being our h when we go from this form to this form. Now, this is not easy, and if I begin to lose you here, don't worry about it because, you know, this is just about stretching your mind a little bit here. What we're going to do is we are going to complete the square on this, okay? Now, I'm going to write this in a little bit of a different form, and it's going to look a little bit crazy, but you should, I hope you'll be able to follow along. I don't expect you to be able to reproduce this. Now, we know we can always go from f of x to y, but we can't always go from y to f of x. So I'm just going to write this as y equal to ax squared plus bx plus c. Okay? Now, when we did completing the square before, we always had it equal to a 0 here. We're not going to have that. We're going to have to keep our y around for a little while, and then we're going to end up solving for y again. But this is all transformation. You may not completely understand why we're doing this, but I think you'll be able to follow. Now, ignoring what happens over here. If I'm going to complete the square on this, our first step was to divide everything here by an a. So, and whatever I do to one side, I have to remember to do to both. I have to do it to everything. So if I divide this by a, I have to divide this by a, and also the y by a. Okay, now I'm going to flip my equation around just because I just generally like my x's being on the left. So this simplifies to x squared plus b over a x plus c over a is equal to y over a. Okay. Now our next step was to get our constant over on the other side. We used to say our constant alone, but that was when we had a 0 where our y is. But I'm just going to subtract c over a from both sides. Okay. Now this gives me x squared plus b over a x. I'm going to leave myself a little space here. And this equals y over a minus c over a. Okay, and again, a little space, because I'm going to add the quote-unquote magic number to both sides. And to find the magic number, we take the number in front of our x, which is b over a, and we divide it by 2, which is equivalent to multiplying it by 1/2. That gives me b over 2a. And then we square this. b over 2a squared is b squared over 4a squared. And that's what I'm going to add to both sides. Okay. Now, if we've done this correctly, this is a perfect square trinomial right here, and this should actually feel very similar to what we did when we were developing the quadratic formula. All right. This factors as x plus, because that's a plus sign, it's always the square root of this, which is always what's right here before you squared it, b over 2a squared is equal to y over a. Let me get a common denominator right here. Negative c over a is the same thing as negative 4ac over 4a squared. So what I have right here is I have b squared minus 4ac over 4a squared. Again, that should feel very, very similar to what we were dealing with when we developed the quadratic formula. So this is plus b squared minus 4ac over 4a squared. Okay? Now, what we've done is we've completed the square. We're kind of getting towards this form, but we need f of x equal to, which really means getting my y back alone. So I'm going to move all of this over to this side by subtracting. So I have x plus b over 2a squared minus this whole thing, b squared minus 4ac all over 4a squared. And I'm just going to turn my equation back around. This is equal to y. No, sorry, y over a. And then the last thing I need to do is I need to multiply both sides by an a, which means multiplying this entire thing by an a. And that gives me y is equal to a times x plus b over 2a squared minus, when I multiply a times this a cancels out one of these, so I have b squared minus 4ac over 4a, not over the 4a squared anymore. Okay, so this is f of x is equal to a times x plus b over 2a squared minus b squared minus 4ac over 4a. Now let's compare this to this formula right here. A is still a, and if you remember when we learned about this other version, we said that a is the same, and you can see that it definitely is. X minus h. Well, this is x plus, so in this case our h value would be negative b over 2a. hk, but our h is negative b over 2a. This is exactly where this comes from. And I think you'll see why we write it like this, because if you go from this formula, you could also say that your k value is negative b squared minus 4ac over 4a. And you could use this for this f of negative b over 2a, but it's much easier to think of it as this way. So just so you know, these formulas don't come out of nowhere. They have very definite meanings. They come through mathematics, and you are capable of generating these yourself.